Dear student, welcome to the online learning. Today we are going to learn about chapter number 5, that is understanding elementary shapes. Today's topic will be 3D shapes and perpendicular lines. So let's begin with our today's learning here, children. So before we move to the three-dimensional shapes, you might remember that we discussed about the two-dimensional shapes in our previous topics, which basically deals with the flat shapes like line, curves, polygon, etc. So that can be drawn in a piece of paper. But children, a shape with three dimension is called as a three-dimensional shapes, and these shapes they include the shapes like cube, cuboid, cylinder, sphere, etc. Okay, so these three-dimensional shapes are the solid shapes. Okay, and you might have came across with this types of shapes in a real life, okay, or in your day-to-day life. So they are not the flat shapes, fine. So you can see this shape, okay, it is a shape of a ball, okay. So this represents sphere. In the same way, if I talk about this another, you can see this is a ice cream, and this ice cream represents a form of a cone. Now look at this another picture. You can see it on the screen that it is a shape of a can which represents cylinder, fine. Now see here the another shape, that is a playing die, so this represents a cube. Okay children, now you have seen this figure, you are very familiar with this. Okay, so you can see this is a matchbox. Okay, so this look like a cuboid. In the same way, if you look at this picture, okay, so this picture it is a shape which represents here a pyramid, fine. Now look at this, so the tent here is in the shape of a prism. So now for all that three-dimensional shapes, we will be discussing about its faces, edges and vertices. So let's deal with each of these terms one by one. So look at this figure. As you can see, it is a cuboid. Okay children, so for this we will be finding the number of faces, edges and vertices. So if you talk about the number of faces for this 3D shape cuboid, okay, so you see here the front face, this is the first face. Same way if you talk about its back region, okay, so it is also having a rectangular region, so that will be the second face. Then if you see from the right end, okay, so this rectangular region includes the third face. In the same way, if you talk about the rectangular region present towards the left hand side, so that includes the fourth face. In the same way, if you talk about the upper top rectangular region, so that includes the fifth face. Okay, and likewise if you consider the bottom rectangular region, fine, so that is also the another face, which makes total 6 faces for this cuboid shape. Okay children, now if you talk about its edges, so let us calculate total how many edges we have for each of its face. So when you talk about its edge, okay, so you might be remembering that the two adjacent faces of this cuboid meet in a line segment. Okay, so you can see this is the face and this is the another face, so both are the adjacent face, so they both are meeting each other through this line segment. Okay, so total how many line segment we have? See here, 1 2 3 and 4. So how many edges we have in each face? 4 edges. Okay, now let us discuss about the vertices in each faces. So you might know that what are vertices, children. So when you see the three edges of a cuboid, they meet at a point. So when you talk about this is the first edge, this is the second edge and this is the third edge, so here is the first vertex. In the same way, if you talk about this is the first edge, second edge and third edge, so this is the second vertex. Now see here, this is the first edge, second edge. Okay, and when you have this another line here, so that will be meeting here, that will make the third vertex. Okay, and in the same way, if you talk about the last vertex, okay, so that will be obtained when you see here, this is the first edge, second edge and the third edge, so all these three edges are meeting each other, so that makes the fourth vertex for this cuboid shape. So we have total 6 faces, 4 edges and 4 vertices for each faces. Okay, then look at this another 3D shape. It is a cube. Okay, so for this it is same as like cuboid, but here all the sides are of equal measure. Okay, but when you talk about cuboid, here the all the lengths are of not same measure. Fine. See here, as like the cuboid, it also has total 6 number of faces, children, and for each face, if you talk about its edges, so in the same way you will see first edge, second edge, third edge and the fourth edge for this cube shape also. Now if you talk about its vertices, so in each face how many vertices we have? So here you can see for the you can see the first edge, second edge and the third edge, they all are meeting each other at this corner at this vertex. So okay, one first vertex, then this is the second vertex. In the same way you can see here the third vertex, and this is the fourth vertex. So total 4 vertex in each face. Now let us discuss for this triangular pyramid. So children, here in this triangular pyramid we have total 4 number of faces, as you can see through the figure also. This is the base face, and this is the side face, and this is the left side face, and when you see here this complete face, so this is the triangular face for the front side. So total 4 number of faces we have in triangular pyramid. Okay, now if you talk about each faces, okay, how many edges does it have? So for each faces if you talk about, so you can see here, let us see this bottom face. So 1, 2 and 3. So how many edges we have? 3 edges. Okay, now if you talk about its vertex, okay, vertices, so total 3 vertices we will be having for this triangular pyramid. How? Let us see. So you can see 1, 2 and this 3. So 3 edges they are meeting at this corner. So this is the first vertex, then 1, 2 and 3. So this is the second vertex. In the same way 1, 2 and 3, all these 3 edges meeting each other at this corner. So this is the third vertex for the triangular pyramid. Okay, now see here the square pyramid. So children, here we have total 5 faces. Now let us see how. So you can see the base, okay, the base of it. So the base face of this square pyramid is in shape of square. Okay, and the rest other 4 faces, they are in form of triangle. First, second and the back side you can see one more triangle, and this left hand face also if you see, that will be a triangle. So total 4 triangular face and 1 base of a square shape. Okay, so total 5 faces we have in a square pyramid. In the same way the total edges if you count, 1, okay, 2, 3, 4, then this is 5, 6, this dotted one is 7 and this one is 8. Okay, now in the same way if you count its total vertices. Okay, so how many vertices? Let us count 1, this 2, 3, 4 and 5. Okay, now let us discuss for this triangular prism, children. So you can see here this also has total 5 number of faces. How? Let us see. As you can see the base one, this it is in form of triangle, as well as the top also you can see it is in a form of triangle. So we have here base and a top as a top faces as a triangles. Okay, and the rest other faces are in rectangular form. So let us see how many rectangular faces we have. 1 and 2. 2 faces are of triangle type, and then you can see here the base one face. So this represents the triangular face, and then this right hand face you can see. So that is also in rectangular, as well as when you see it from the left hand face, that also represents the rectangular face. So total 3 faces which are in form of rectangular shape. So total 5 faces, 3 triangles and then 3 rectangulars and 2 triangle faces. When you add, you will be getting total 5 faces here. And then if you talk about its total edges, okay, so total edges when you are counting, let us see here. So 1, 2, 3, fine, then 4, 5, 6, 7, and this is the 8, and this is the 9. So total 9 edges we have here. And for the vertex, if you count, so total how many vertices we will be getting? 1, 2, 3, 4, 5 and 6. Okay, so triangular prism has 5 faces, and edges will be 9 total, and total vertices will be 6. So remember this, 2 triangular faces we have and 3 rectangular faces we have. So total 5 faces. Now come to the exercise 5.9. Look at this shape, you have to tell. So your instrument box look like cuboid, yes. Then look at this brick, so it look like which shape? It is also like a cuboid. In the same way, if you talk about matchbox, we have right now discussed, so this is also a cuboid. Now if you talk about a road roller, so this represents cylinder. Now if you talk about the sweet laddu, okay, so that represents the sphere. Now let us learn about the perpendicular lines also, children. So children, when you see any two lines intersecting each other and they make an angle between them that is equals to 90 degree, okay, then that line we say it as a perpendicular. So see here, we have a line AB, and this line is getting intersected with the another line segment, that is CD, and both of them, they share a common meeting point, okay, that we have named it as O point. Okay, you can see this line segment AB is intersecting the another line segment CD, and they are sharing a common meeting point, that is O. Okay, and even when they are meeting each other at this common point O, they are forming an angle of 90 degree, right angle. Okay, so we call this line as a perpendicular line. So you can see CD is perpendicular to line AB. So here this line segment CD is dividing the another line segment AB into two equal parts, that is AO will be equals to OB in measurement. In the same way, we say CD is a perpendicular bisector of AB. Okay, now come to the exercise 5.5. Here we have to assume that PQ is the perpendicular to the line segment XY, and here PQ and XY intersect at point A. Right now we have discussed, in the same way we have to solve this question. So we have drawn a line segment XY and another line segment as PQ, as it was said in the question that PQ and XY intersect at a point A. So you can see the common sharing, this meeting point, the common point which they are sharing, that we have to name it as point A. Okay, that we have written here. Now we have to tell what is the measure of angle PAY. So see here, PAY, what is the angle form, children? Come on, tell me. Yes, it will be the 90 degree angle. So we can write it here that angle PAY will be equals to 90 degree, because here PQ is the bisector of line segment XY. We can say this line segment PQ is the bisector of line segment XY. So we have got an angle PAY is equals to 90 degree. So come to the question number 4. You have to study this diagram, and the line L is perpendicular to line M. Okay, so you see here this figure, and one by one we will be dealing with question. So CE is equals to EG. So see here, where is C? This, and where is E? This. Okay, so C to E is how much distance? You can see C to D is 1 unit and D to E is another unit, so total 2 unit. In the same way, let us see for EG. So E to G, again you can see we have a 2 unit gap. Okay, so we can say yes, they are equal. Now we have to say, does PE bisect CG? Okay, PE, you can see this vertical line PE bisect CG. Okay, so we have to tell this answer. So what we'll say? Yes. Why? Because you can see this PE, okay, is perpendicular to line CG. Okay, because C to E is 2 unit and E to G is again 2 unit. So PE is bisecting CG. Now we have to identify any two line segment for which PE is perpendicular to line perpendicular to bisector. Means we have to identify two line segment for which this PE is the perpendicular bisector. PE will be the perpendicular bisector. So you can see we can write any line segment. DF we can write because D to E is 1 unit and E to F is also 1 unit. Or we can write C to G also as a line segment, for which PE will be the bisector. Why? Because C to E is again 2 unit and E to G will be 2 unit. Okay, so we can write D, E, and we can write what? We can write C, G. Okay. Now come to the home assignment, children. You have to solve question number 1 and question number 1, 2, 3